Let's go. Good morning, good afternoon, good evening, good dawn, good whatever, wherever you are. This is IoT Tuesday with yours truly, Samuel Atrani, bringing you another episode of the IoT Tuesday show. As you all know, on the show, we try to demystify IoT to the barest minimum. We make, we break, we hack, and then we learn and have fun. Most times, fun doesn't come with, some challenges, and we go through all that on the show. If this is your first time joining, welcome. In today's episode, we're going to have part 6, which is going to be the final part of interacting with the Azure SDK for C embedded Arduino. That's going to be the end of that series. However, we're going to have another series of, sending data from ESP32 to Azure IoT, either through IoT Hub or IoT Central. I'm going to explain all that in the subsequent series that we're going to have. So if this sounds like something that is of interest to you, don't forget to subscribe to the channel so that we can grow the channel and bring you more content. Before we get into today's episode, let's go for our intro. Awesome, we're back. If this is the first time you're joining us, welcome to IoT Tuesday. Yes, truly, Samuel Adrani. Well, in last episode, we had a challenge. We had our board throwing out some crazy errors and stuff like that. So we couldn't send a telemetry. However, painfully going through documentation, research, hitting the wall, and all sorts of things, we finally able to send the data to the cloud, which I'm going to show you today. However, it's not going to be devoid of the challenges I have. And that's the reason why I do the show, to share some of the learning process and things I've gone through whilst bringing you the episode. So today, we're going to go through some systematic process of, dealing with the issues we had last week. Now, for those of you that don't know what happened last week, I'll probably leave the link somewhere, either up here or down somewhere in the video. I'll leave a link here. You're going to see it, and also probably drop in the description so you can see what happened in the last episode. However, going through it. So first thing, what happened was I was connecting the ESP32 board. I was connecting it to a USB hub, which is connected to my computer. So it wasn't directly connected to my computer. So that meant that anytime I ran the sketch, I loaded the sketch and I was running, it wasn't getting enough power. And there is an inbuilt protection thing that, protects the board, ESP32 board, from, messing itself up or, whatever that is, if the power is insufficient. So that kept giving us that error. So to solve that problem, I had to directly connect the USB cable to my laptop or to your computer, whichever form you're using. So it has to be directly connected to it. Or if you're using a hub, you need to probably power the hub to give it enough power. So that was the first thing, and that solved the problem. So now we are able to successfully deploy the sketch onto it, and it sends the data to IoT Hub. So that was a challenge for the very first. That was the very first challenge. So to show you that, let's go ahead. Let me show you the bench. Sorry, the bench is a bit messy today. I have a couple of things I would share, so I'm going to leave them. Let's bring this a bit here and adjust this. All right, so we still have our temperature humidity sensor as always. The bunch of things there I'll talk about in today's episode. So very simple configuration. I'll share the sketch as well. We have our DHT11 temperature humidity sensor, this one connected. Where is that? Yeah. We have this connected to the ESP32. So the ground pin is connected to the ground on the ESP32. The VCC or the power pin is connected to 3.3 volt on the ESP32. And the data pin is connected to the pin 4 of the ESP32. So quite simple, nothing crazy. So I'm going to go ahead, connect it, and then we'll try to look. I'll run the ID for you to see what's happening. So let's go ahead and load our IDE. And for the purposes of today's session, I'll be using I won't say old, because 2.0 is not still released. There's a release candidate, but it's not been released. And I'll talk about that in today's session as well. So I'm using 1 point. I think my current is 1 point something, 18 or something. So I'm going to use the current stable version of the Arduino IDE. Now, so and then we would do that. So first of all, let's just go ahead. I'm going to, this is the code, and I'm going to just make sure the code is running fine. Then I'll connect the ESP32 to it, and then we'll run and see how that works. Now, before we continue, I would also address certain questions I had over the the week, asking about reasons why we're going this long route, and I'll explain that shortly. So maybe I should use this opportunity to address it whilst we're waiting for the sketch to compile. So let's go ahead. So there was a very common question that people kept asking was, Sam, there are several ways you can connect, you can send data to Azure IoT, whether through IoT Hub or IoT Central. So why are you going through this? This looks like it's been a long journey. It's painful, you know. And yes, that is true. If you've been following keenly, this SDK we're using is specifically for, you know, one Arduino enabled board, so to speak, or Arduino compatible board. All right. Now, most of you have, those of you, if you've been following my channel, you've seen me connect and send data to Azure IoT Hub and IoT Central several times. The very common one I did was I used a Raspberry Pi, which was running a Node application. Yeah, it was running a Node application on the Raspberry Pi, and that was connected to Azure IoT using the Azure IoT SDKs, right, for Node.js. Pretty simple, no stress, works perfectly, nothing wrong with it, right? Now, you can do that with other, you know, boards and other devices. No problem with that. You can do that with .NET, no problem. However, the challenge here is that for low footprint, especially devices that have constrained resources and power, all right, like the Arduino enabled ones, cannot run things like Node.js. They can't just run it, all right. And by virtue of that, you'd have to be writing things like, you have to write C, all right, C++, which is the regular thing you do in Arduino, all right. So the SDK provided us the opportunity to make it easy for you to, you know, interface with the Azure IoT SDKs, right, to be able to send it. So that is why we're going through this process. Now the question is, why do this? Not everybody has access to Raspberry Pi. That's one, all right. You might have, now ESP32's ESP8266 are now mostly widely available. So you might have that around. And the reason why we want to learn how to do this. And now, it's a painful process, but trust me, once you're able to do that, makes things easy. Then the second question I was asked was, why didn't you just go through Azure IoT Central, right? Just go through Azure IoT Central and then have it, you know, pretty much straightforward. You're doing setting up this, setting this up. Now, if you didn't know, and I'll share this today, Azure IoT Central is a PaaS offering. And when we say PaaS, Platform as a Service offering from Microsoft. Now, beneath Azure IoT Central is Azure IoT Hub and a varying array of the other Azure IoT services. All right. That makes it easy for you to deploy. So if you want to kind of like it's plug and play, you know, quick to go. You don't need to worry about setting up hubs, setting up all these routes, set interfaces for your dashboard, commands, alerts, rules. Pretty much Azure IoT Central handles all that for you. If you want some, now there's a level of control you get from Azure IoT Central. However, if you want to go bare bones and be able to do, you know, things that you cannot immediately or easily do from IoT Central because of setting restrictions, then what we are doing is what you need. Being able to provision your IoT hub, sending data to the IoT hub, and then deciding to do whatever you want to do with it. All right. So what I will do as a follow-up is, now that we're going to get the data into IoT hub, the next thing will be, okay, now how then can I act on that data? Do I want to use Stream Analytics to do something? Do I just want to send the data into another event hubs and then trigger something or send SMS or do whatever? We'll do that in subsequent episodes, but that will not be exploring the SDK. The SDK is done. So we're going to concentrate on, you know, Azure IoT Hub and IoT Central for a while. before we do a major project for the year, which would be building a smart AI bin. An AI-enabled smart bin. Yeah, I have to find a wording right. Now, that's going to be an AI-enabled smart bin. And I'll give you some gist on that. It's not something new, but we'll see how we can build that from stuff around us. All right, cool. So that's it. IoT Central is just a PaaS offering that puts together everything that we've been doing. So IoT Hub and the other services. So that's the two reasons. All right. Now let's go to the board. Let me also share this. So there was also a question. Well, Sam, why are you stressing yourself connecting this when you could use this, which is the official or one of the dev kits that, which is the ESP32 Azure IoT dev kit. All right. Now, if I should hold it this way, now you should realize that this has a few, this is actually packed. And I think I explained this in the last episode. This is packed with a lot of sensors. All right. So you can easily use this to test a few things out. However, consider that the type of application we want to build, you don't have the sensors you need on this board, okay, on this dev kit, but rather you would have to connect. So I gave an example last week that assuming we want to use this capacitive soil, moisture sensor, and then maybe this ultrasonic, sensor. These cannot be found on this dev kit. Is that okay? So you would need to understand and learn how to do this route to make things a bit easier for you. And the more reason why we are doing this. And as a homework, you can, once we're done with how to do it, you can easily go, mess around with that. All right. So that's just by the way. Great. So with that out of the way, now we have, okay, we now have our board here. As you can see, the sketch is compiled. So let me go and connect it. Let's do this. All right. So let's go back here. So that is connected. It's already deployed on it, but for the sakes of, I'm just going to deploy it again. Now, once the deployment is done, or once the deployment is happening, I also want to talk about the code refactoring I did to make this cleaner and easier for you to understand. Now, you realize that if you use a sample code that comes with the SDK, right? It gives you IoT config, which is where you put your, SSID password so that you'll be able to, connect to your Wi-Fi. Then it gives you serial logger and a bunch of files. All right. Now, the main file had a lot. Okay, good. So our data has been sent. The sketch has been loaded onto our ESP32. So don't worry, let's talk through this and then I'll come back to you. So it's running right now. I'll show you what's happening. Now, so what I did was I created a new, .h file. Now, what I did was to abstract all the, constants, definitions, variable declarations, utility functions, all those at this point, technically code you didn't have to do anything to. I moved all of them into the setup.h file. All right. Move them into that file. Now, what this means is that you now have the barest minimum code here to do your work. So you're not conflicted with all this crazy. And I will leave, I'm going to put this on GitHub and I'll leave the description to the GitHub, on here for you guys to go check out. So if you look at this, we're including the setup.h that brings all the other, functions and variables, everything here for me. So in this case, my sole purpose was to make sure that you could just pick this file or this solution and just use it like you're using any regular Arduino project. All right. So you can see, just include your libraries for DHT sensor. So if you wanted to use the capacitive soil sensor, you just bring in the library, set it up, and then here's just a few variables just to help, a few, functions to help with the work. And pretty much you have your setup and loop, and then you do your stuff. Very easy. Now, there's this common thing you see here. Here we are reading auxiliary function prototypes. Now, by documentation, right? What happens when you have an Arduino sketch is that it creates what we call the function prototypes. Now, if you've done programming before, sometimes, you would, assuming you try to use a function that is not already being declared, all right? Or using a variable that is not already being declared, you're going to get an error because it will tell you that it's not being declared, all right? So function prototypes are a way to tell the Arduino compiler that, hey, look, there's going to be a function called initialize sensor, get telemetry payload, send telemetry JSON, right? There's going to be a file with that name, okay? There's going to be a function like that. It's somewhere in the file. So when you come across it, please make sure you compile or you find it in the sketch, right? So that's just all that means. So if you look at it, the actual definition is all happening, after your regular setup and loop, right? This is your basic Arduino sketch, setup, loop, and all that. So right after that, we're defining. Now, however, if you are going to define all these auxiliary functions above, right, above here, then you don't necessarily need to do, this function prototypes. It's not needed, all right? But again, just for good practice and organizing your code very well, I choose to do this so that anyway I put it in there, it makes the work easy. So as you can see, quite simple. We only have initialize sensors, which I've created here. Let's take it. As you can see, it is just your basic here. It's just a basic setting up or initializing your sensors that you're going to use, and then the get telemetry payload. Now, get telemetry payload is one of the default functions that come when you download the sample SDK project. So all we have done here is to include the DHT. So get the DHT sensor values. So for humidity, temperature, and Fahrenheit, all right? And then we're just sending it. So this is where we're having the challenge. First of all, is the power. Once we resolve the power. Now, this is tricky, and I'll come to talk about my experience with the SDK so far, and then I'll give you my honest opinion. Now, this was a tricky part. Now, to send the payload to Azure IoT Hub, you needed to create the payload, all right, before you send it, right? So in here, the default, and here again, the default code base. Let's actually make this a little bigger. There you go. Now, the default code base, when you download when you clone the repository, is something like this, right? That creates, and I'm sure you've noticed something like AZ span. We'll talk about that. In a bit. Now, so this is how technically it's trying to create a string that looks like a JSON object. All right. That is what is in the default SDK repo. So how does it do that? So basically, first of all, I'm creating a span, an AZ span. Sorry, it's the payload object. I'm creating an AZ span of a string type that's going to have message ID, and they are using escape. They are escaping it so that we can have the quotation marks when we are generating the JSON object. All right, and this is just by default the SDK code, nothing crazy. And then here, adding a payload count. Now, if I wanted to add another, let's say, property and value, I have to do this again. So in this case here, I'm creating a property called temperature. And then if you look here, T from above, T here is a temperature in degrees Celsius. All right. So here, appending T to it. So if you look closely, I'm trying to do, something like temperature colon the value, message ID colon the value, humidity colon the value. That's what I'm doing. All right. That's all I'm trying to do. And this is how to build on it. So I have a payload object. I keep adding to it. And when that is done, there is this, making sure that the size of the payload and all that is, so there's no, leak or buffer overflow and stuff like that. Set that into the payload. And then I can now send that to the, to the Azure IoT Hub, which is done by this send telemetry. This is also default. We didn't have to write this. This was default in there by the SDK. So pretty simple, right? So there you go. First of all, it needs to make sure there is a topic to send to. And if that's fine, then it goes ahead to call the get telemetry payload, right? Passes the reference for that object. And then it uses the MQTT client to publish it to that topic, right? So this is it, telemetry being sent, right? So pretty much you say straightforward, right? If there's any error, it's going to say it's an error, and that's just it. However, I'm going to talk about this, but before we talk about this, let's now go and see how the data is being sent. So if I go ahead to tools, serial monitor, that's going to come somewhere here. And for the sakes of all I'm going to do here, let me bring this in view, is just to restart or reboot so that it will reconnect again. You can see. So there you go. So it's published the temperature and humidity. So it sent it. All right. So I've deliberately put a serial log there so you can see. And by default, we've set this to send it every 30 seconds. All right. This can be changed in your the config.h file. You can set it to 10 minutes, 15 minutes, whatever you want. But if you're using, you can put in some, there you go, so now temperature is 32 degrees, humidity is 26. So let me do something. Let me blow some air into this, and then let's see what happens. And then after that, I'll share some info. I'll tell you something. There you go. All right. So you can see that the humidity jumped from 26 to 30, and the temperature, well, pretty much temperature was in around the same time. Good. Now, this is just, now the question is, I'm just showing the serial logger. How do I know it's being sent to IoT Hub? Well, I'll show you in a sec. Now, the other thing is that one of the reasons I forgot to mention, the reason why we're going this part also is that if you want to use IoT Central, the last I checked, you can create a trial IoT Central application that's valid for 7 days. Yes, that's a lot of resources spent for in the behind the scenes. And after 7 days, boop, that goes off. All right. So considering that we are running a continuous series, it makes sense for me to, if I'm just showing you IoT Central in a one-time series, one-time episode, that's fine. We can do that. There's no problem with it. But to continue building on it, I can use IoT Hub free so far as, and I get, I think, about 80,000 messages in a day. So, and I can be smart about the way I send telemetry. One of the ways you're seeing here is either reduce the, increase the time it takes for the telemetry to be sent. So you can see 3351, or if you have to send, if there is a must for you to send it regularly, then what I can also do, which I did in my Raspberry Pi demo, was that you could only check, and then if the telemetry, it's just applicable to any telemetry. If the previous telemetry value has not changed, there's no need to send it to the cloud. Does that make sense? Because that value is already sent. We're tracking it, right? So unless, of course, there is a change in it or spike in it, then you can send it to IoT Hub for whatever to happen. So that's another way to reduce your usage of it. So one of the reasons also why I chose to do this as well. Okay. So now this is the current way of sending the telemetry. All right. No issue. At this point, everything I can see that is being sent because I'm seeing published successfully. Well, let's reduce this, right? Now, that couple of ways you can see the telemetry being sent to IoT Hub. You can either do it in IoT Hub itself, or in this case, we're going to use two ways. The first is to use the Azure CLI. All right. So let's go ahead and open the Azure CLI, which is the AZ CLI. All right. I'm going to increase this a bit, and you know what? I'm going to bring this. Well, you can see this, so that's fine. And let me bring, where's the serial monitor? Yeah, I want to put the serial monitor also here. Let's put the serial monitor on the side somewhere here. Yeah, let's leave it to auto scroll. That's fine. And then I'm going to put the, yeah, let's do this. Yeah, that's good. Okay, so if you want to monitor the events that are going through an IoT hub, now I'm going to show you a few things which you should be mindful about. Okay, this got me a couple of times, so I'll explain to you. Now, to use the, so this is it. Okay, so first of all, let's just copy this. All right, and let me start with this so you can easily understand. Now, so it's AZ or AZ IoT hub, then it's monitor event, right? It takes a parameter of the hub name. If you remember, ours is IoT Tuesday. And then the device ID, if you remember from the episode, it was IoT ESP32, right? That's a device. Now, most of the documentations will tell you to do this, okay? If you do this, you're going to end up in a potential error like this, which is going to show, it's going to error out. Now, this is the reason. If you have an IoT hub that is being used, all right, by multiple devices or multiple applications, right, it has a default endpoint, right, or a default consumer group that allows you to, you know, read telemetry that is being sent to it. Now, if this is your hub, okay, authorization timeout. Yeah, all right, we'll just have to log in again. Now, if your IoT hub is being used by multiple applications or multiple applications with multiple devices, then you're going to get an error. Let's quickly do this. That is easy login. Let me log in really quick so that we can see this. So this is going to open an authorization window. Where is that? Let's do this. And yeah, it's just an authorization window for me to log in. And I need to have my second factor authentication ready. Yeah, as you can see. So let me go out here. So I'm just going to log in, use a different account. Okay. Okay, so this is going to ask me to verify, and it will come back here and just tell me it's going. Now, if you're using AZ login, make sure that you are logging into your Azure account that has your IoT hub, or that has your Azure resources. Let's put it that way, right? Don't log into another account. Make sure it's the account that has your Azure resources, right? Cool. All right, with this done, we can close this, and then it would log in and tell me that everything is okay. Now, I took it off the screen because it's going to share some sensitive information about my account. So that is why I deliberately move it off screen so it doesn't throw or share such sensitive data on the stream. Because don't forget, this is also going to be on demand. There you go. So CLS, let me clear this and bring this back here. All right, cool. So same thing. So now, like I was saying, this is it, you know. So AZ IoT Hub, monitor event, the hub name IoT Tuesday, the device name is IoT ESP32. Now, if you have the Azure CLI installed, you can also install the IoT extensions pretty easy. I think I showed that in the beginning of this series. Now, this is going to error. Why is it saying authorization timeout? Could it be because I'm using all the other stuff? Yeah, because I'm running a lot of things in the background. Okay. This is interesting. Okay, well, let me just go ahead and explain and just go. You would encounter an error if you have multiple servers on. So the way to counter that problem, right, is to use what we call consumer group. Create another. There's a default consumer group, but you need to create another consumer group, which you can now use to get telemetry from the IoT hub, telemetry that has been sent to the IoT hub. All right, so let's see, where is that? So let's go ahead and do this. I'll try to log into what? So portal.azure.com. Now let me try this. While this is done, let me just try and go. So in order to solve it, like I said, you need to add the consumer group. All right, so -- consumer group, and I created a consumer group called telemetry. All right, so you can use that consumer group to now get the information. As you can see on the left, data is still being sent. All right, so let's try this again. I hope it doesn't time out. If it times out, I don't know. We'll probably just stop this and then use something else. Maybe it's because of the stream. So just, yeah, and don't forget, if you have any questions, please drop it in the chat and I would share that with you. Well, if it tries to misbehave, I'll quickly I'll connect. Okay, there you go. So see that? Awesome. So it didn't time out this time. So now, because I specify that the consumer group called telemetry, you can see that now anytime there's a publish in the left, which is the serial monitor, you see the payload. And you see the way the payload is coming. It's just the way I define it. Now, that is not the ideal way to send a JSON payload, which is what ideally you want to do, but it has to be a serialized JSON payload. All right. So as you can see, another one was sent, and then you can see here 3132. So 3132. This is the 36th message that has been sent since we rebooted it. So as you can see, this is going to the IoT hub. This is going to the IoT hub right now as we speak. All right. Now, again, this is the current way of doing it, and this is how you view it. Now, the first part, like I mentioned, is to use the CLI, right? Which is this. So there you go. Another one has been sent. So that is the AZ IoT hub, monitor events, the hub name, the device ID, and the consumer group. I'll show you how to create the consumer group shortly. So that's the first way to do it. Now, the other way, if you remember, I mentioned is to use the IoT Explorer. And we saw in previous episodes how we set up the IoT Explorer, how we got the connection string, and then how we used it. All right. So it's the same thing here. I'll use this to connect. Now, this is where it gets confusing. So as you can see, we have two edge devices, the ACI cam and other perception. We don't want to go to, but what we are interested in is the IoT ESP32, this one here. All right. So let's select it. And now if you look closely, you should realize that now if you go to telemetry, okay, and it's the same thing. By default, like I was mentioning, there is a default, okay, there's a default consumer group, which I mentioned will not work in your case if you have an IoT hub that is serving other applications and other devices. However, if you have a brand new IoT hub that is what you're using for this particular application, it would work fine. Default consumer group will work fine. So I need to make sure that this is set to telemetry, right? And then I can now click here on start. And then what's going to happen is that it is going to start showing the telemetry as received from our IoT, our ESP32 and the DHT temperature sensor. Now, something funny happened, or something funny is going to happen. And you'll be like, wait a minute, Samuel, you just showed us in the CLI and we could see the payload. Okay, so an event has been sent. Yeah, it takes a while for this to warm up, but it's going to come up. Oh, I don't think I spelled it correctly. It's not going to work. Telemetry. Okay, it should be correct. I suck at spelling, guys. Telemetry. Telemetry. Okay, it's going to come. Let's just give it a while. Now, the funny thing that's going to happen. Okay, there you go. It's just in. Yeah, patience. Someone, you need to have patience. Now, do you see the funny thing? So the question is, Sam, wait a minute. You showed us the telemetry in the CLI and we could see the payload. Why are we seeing a bunch of this? Yeah, that's the gotcha. So, like I mentioned, if we go back to our sketch, right? Right here. You see this? Message ID, temperature, humidity. We were building this. Now, this is a span, AZ span, right? Which is just a pointer to some byte and, buffer and an array. It's just a pointer to it, right? It's a struct. It's a struct that has the pointer to that byte and the buffer, right? Buffer size, right? Supposed to make it easy so there's no overflow, there's no leak. However, that was very complicating. So, like I mentioned, this here in the default, by default, the default code you get when you download, when you clone the repo, that is not the ideal and best way to send. This is not like this. Yeah, it's JSON anyway, but it looks as if the type has not been, for some reason, the type has not been properly set for it to know, hey, this is a JSON payload, and treat it as such. So the workaround or the solution would be to let this send a proper JSON payload. And to do that, you need to leverage on something they're calling AZ JSON. That could be like that. That's going to be for another episode. Trust me. I spent the better part of the week trying to figure this thing out. And I'll give my verdict at the end of the show today. So don't worry, we'll get into that. So that is why you're seeing this in bytes. So it means that for this to happen, you need to, decode it or deserialize it in some ways to get the actual data, right? So these are the two ways, aside from the Azure portal, that you can do this, right? Using the IoT Explorer and then also using the CLI, all right? If we bring the CLI up here, you would see that it'll be like, wait a minute, what's happening? It's the same data. And just to show to you that it's the same data, I'm going to minimize this and then I'll bring the CLI up again, all right? And we'll put the CLI side by side. We'll put the CLI side by side, the IoT Explorer. And then you see that it's the same thing, all right? So here, if you look closely, anytime there's a new one, it's just going to go down for you to see. So let's get this running. And so for a long while, I was like, what's happening? What am I not doing right? Like the serial monitor is showing it, I'm getting it. And then, research like, well, it's not really. It's kind of like the type is not. Yeah, let's do this again. I don't know why, but it's just for some reason. I don't know. Maybe it's just connectivity because I have this, I have that going. But I anticipated this happening because I'm having connections to it. But anyway, that should work, hopefully. If it doesn't, we'll just stop one. I'll just show you something else and then we'll move on to today's business, right? Which we've seen how to send the telemetry. But next steps would be my thought, my idea. Okay, well, I think I'll have to stop. I'll have to stop this for that to function for it. But we've already seen that, so no worries. Now, there are, so let's bring the serial monitor. Good. Now, so that's it. So you're sending the telemetry. This two shows you that telemetry is going. So if you want to see the body, which is going to be the payload, it means that you need to send a properly formatted, JSON formatted payload, all right? Which you have to use the AZ JSON, okay? So that's it. Now, before we move on, I'm going to show you how to send cloud to device message here. So be looking in here in the serial monitor. So we want to send a message of hi from the cloud. We want to send it to this device, okay? So all we need to do is write this and then I'll click send here and just keep looking in here. You see that it's going to show up in a serial monitor because we have event handling it. I think it was sent, right? Did it? There you go. Look at that. So down here, you can see hi from the cloud, which we just sent from here. All right. So if I say hi from the cloud again, and push this. So we'll try to send it. So that is how now we are able to send telemetry to the IoT hub. And at the same time, we're also able to send messages from the cloud to the ESP32. Now, there's also direct method. We've not created any method yet, but the concept of that being, if we had functions defined on the ESP32, let's say you have connected a relay, right? Or another output sensor, all right? And based on the temperature, let's say if the temperature was pretty high, right? You could send a command or a message to the relay to say, hey, turn on the fan so that we can, get some air circulating in it. Or if you have some infrared blaster in there, you can send a command to say, hey, turn on the air conditioning and open the blinds, so some cool air, can circulate to reduce the temperature in the room. So that is how you would do that. Okay. That's how you would do it. Now, my candid opinion, all right, so far, let's just go off the the code and everything as we've seen it working. And yeah, I've not forgotten. I'm going to show you how to do the setting the consumer group in Azure IoT Hub. Now, to my candid opinion, I think the SDK is quite challenging for people to use. I'm not alone. I have been in forums and community talks, and people are most people have the same perception. Now, ideally, we're used to having defined my float, my type, get my data and do my stuff. However, the usage of the AZ span and all those abstraction fairly supposed to make it easy. It's even taking some of us who have been doing this for a while, it's taking us time to grasp and understand how that works. So for someone that is just coming into it, my honest opinion is it's a bit tricky. What I want to see, and obviously it's going to come from people like me and people in the community, is to come up, write tutorials or write articles or write how-tos in dealing and using the AZ spam and AZ JSON. As we speak, I'm trying to redefine that section that is sending the payload into a properly formatted, JSON payload using the AZ JSON. I'll release that in an article in my blogs. Now, with that said, my candid opinion is that if this is not the route for you, if this is challenging for you, there are other routes. And don't forget, the library was specific, Arduino C. Now, which means that it is mainly available to be used in the Arduino IDE. The other options you can use to build this or to do this, that would be to leverage something like Visual Studio Code and the Arduino extension, all right? You could use that. Now, one of the challenges I faced when you're using the current Arduino IDE is that, one, you don't get IntelliSense. You don't get code completion. You don't get, that kind of design time error, check for you. So maybe you're calling or referencing a library that is not there. You don't get those squiggly lines and things, which, if you've been doing rapid development for a long time and you are enjoying all this in Visual Studio and Visual Studio Code, you kind of miss. You don't get that in the current Arduino IDE, but the features are available in the release candidate and the soon to come Arduino IDE 2, which is built on Electron, almost just like the Visual Studio Code IDE, all right? That has all the feature. Now, if that makes it easy for you, you can start using it. There's a release candidate you can start using. I have been using that interchangeably if I wanted to get stuff done. That's one way you go about it. I think I have it here. Let's see. Let me go ahead, all right, and close this. And let's share this. And let me open the 2.0. So you realize that in the previous or the version 1 of the current stable Arduino IDE, the UI was a bit different, and there wasn't a lot of IntelliSense or code completion in there. So let's open Arduino IDE 2.0 release candidate and see the difference. Now that's just one. You can also use Visual Studio Code and the Arduino extension from Microsoft. You can do that. There is a caveat to that, or there's a catch to that. For your project or for Visual Studio IDE, Visual Studio Code, to know all your libraries, you will need to include your libraries in the C++ path, include a folder path, right? So that it knows, hey, this is where all the libraries will live. So I can go in there and then make sure that, I'm linking all the, the locations to all the libraries. So if I use any library in Visual Studio Code, that would work for me. I'll show you that as well in today's session. Then finally, you can use one of the really try-tested tools, which is Platform IO. Really try-tested. If you want me to do a video on how to use Platform IO to build IoT stuff, thumbs up, put it in a comment. I'll do a video about that. Super simple, super helpful, awesome way of building. However, that means you're building the logic. It's not going to be an Arduino sketch. You actually build, you're actually writing, you're just like building any C++ application. You're building it onto your device. All right. These are the ways you can use it, aside from developing in the Arduino IDE. All right. I find that hopefully if version 2 of Arduino IDE becomes generally available, all right, it will be awesome, right? Gives you all that, the debugging, libraries, board management, it looks quite modern. However, for me, one thing I have noticed is that when I use this, even when I have the Arduino IDE version 1 closed, it still is not able to see my my board. It picks them once in a while and then it doesn't pick them at all. So I'm forced to use the old one. So as you can see, this, has, much more intuitive. And as you can see, reduce my code base, quite simple. And here, you kind of get some form of, intelligence. Let's say if I do define, I see loading, it's trying to infer from the libraries and everything and give me some, some intelligence, all right? Or even to make it, let me do this rather. Okay, we've defined a DHT here. So let's go, let me do this here. So if I do DHT dot, hopefully, this will load, this is going to load and infer that, hey, you're using this DHT and these are, possible things you can get. It's still loading, it's loading this from, as you can see. Yeah, intelligence. So you get this from the IDE, right? If you're using this is version 2 release candidate 5, right? So if this becomes generally available, hooray, you can use this, all right? Like I said, makes it easy. Now, if you want to explore the other options, let's close this, right? And let me open this from the command prompt, all right? So I can, so this here is the cd dev, cd IoT. I think this is, I think I did, no, it's just IoT, right? No. CD, let's do this. Let's take it back. Let's look at what we have here. I think it is, it's IoT Tuesday. So let's do IoT. There you go. Yep, this one is here. So if I do cd Azure IoT hub, and let's go ESP32. Yep. So so this is what is being open in our Arduino IDE for us, right? So if I go ahead and say, hey, let's open Visual Studio Code, this folder, all right? So this should invoke Visual Studio Code, which I said it's the other way you can do it, all right? Visual Studio Code. So you can see it loads everything in here. Quite interesting. And there is something you need to know, which I'm just waiting for it to load and I'll show you that. Okay. So in here, as you can see, yeah, pretty much all the exciting things about Visual Studio Code, all the colors, there is that. Oh, so look, it saved that DHT from the other side. So yeah, here, and then if you look at the top right, you see run the code, upload the code, check the code, all right, and then get all that version control if you want to do that. Okay, now, so let's try this. Let's say, so let's do this. DHT dot, open this up, loading. And so you realize that the UI is almost the same or similar to what you saw in the Arduino IDE 2.0 release candidate 5, right? Pretty much the same thing. Yeah, I think, yeah. So yeah, there's a second way you can do it. All right. So if you don't, you realize that if you don't see this, I'll show you how to do it easily. And with this, what you want to do is I think it's still loading. That's why it's still preparing it, because with this, it would show down here. Let's see. Let's save this. Okay, there you go. Okay, now it looks like, well, it's still loading, so you can see that it's still activating the extensions. So it would show you, it would give you the options down here to select. Okay, there you go. So yeah, the server took long to yeah, I don't care about this. Yeah, so yeah, my Visual Studio IDE is still running. It's still loading, so we just keep it good. I think it started already. So let's do this. Zoom it. Zoom it. Yep. There you go. I should always do this. You know, I keep doing this on the show. Anyway, all right. So yeah, so now it looks like it's loaded. So you can see straight off the bat, I'm getting some intelligence. So, you know, here it says that include errors detected. Please update your include path. You know, there you go. So now you realize that. So even visually, I'm getting all this visual aesthetics. And if you look here, let's go all the way down. All right, down here. All right, so here I get the opportunity to select on this point the board I'm using, the port, and then it's going to set the programming, which is the way to flash the firmware onto the device. You get a selection here. All right, but then you can see, look, it's telling me, hey, you're including setup. However, the path you chose, right? The path you chose, setup is not in there. That is because your setup is here. This is setup. Like I mentioned, I've just done the abstractions for setup all here. All right. So I just need to, and there you go. It's telling us, hey, I can't find it. So this is what I was saying, that you will need to update the path to include where you have all your libraries you're using within code. By default, if you install the C++ and the Arduino module, it will try to find them within, you know, the folder, the working folder, or you have to provide another path for it to find it. All right. So that is, so for me, I know that all my Arduino libraries are here. Let me show that. Yeah, I know that all my libraries are in this folder. So as you can see, usually in documents, Arduino and libraries. So it's here in your user space. So all my libraries are here. So what I did was I went ahead to add that into the path, you know, but these are all defined. These are coming from third-party libraries that are being used. So I have to just modify it. Okay. So this is one, like I mentioned, this is the second way to do it. If you want to use the IoT, if you want to use Visual Studio Code, right? So I can say the port, I know this is COM port 6, select it here, and then the board type, as you can see, when you click here, it's going to start loading it. So I know this is it's a Node MCU, there you go. So it's a Node MCU 32, all right, ESP, right here. So I can select any of these. There you go. And then you can now select the programmer type. That's going to load. It's also going to load up for you the version. I don't think I've installed this, so that's why. So we can delve into this a whole show setting this up, but this is an option for you. Now, the other option which I mentioned was, if you go to extensions, I think I had this, but I disabled it because it was always breaking mine, is platform IO. So if you go to extensions, if you go to Visual Studio Code extensions, so there you go. Okay, mine is installed. I've just disabled it. Yeah. So this is it. Mine is disabled. So this allows you, it's actually one of the really cool and very well-known and matured extensions or I would say not a framework or library. Well, framework, library. Oh, well, anyway, any of those that allows you to really build and deploy for embedded devices, allows you to pick boards, all those things. Cool. Again, if you want us to do something on platform.io, just put it in the in the comment section. I'll look at it and we'll create a video on that. So these are the ways you can create it. Now, what's the time? 2 minutes into time, like I mentioned. So let's close this. And now let's go and let me show you how to create that consumer group that you would need for your event monitoring of the data coming into IoT Hub. So where's that? Where's my phone for authentication? Open this up. Yep. If you have any questions, don't forget to, drop it here. There you go. Send a notification. Yep. Approve this from the phone. Facial recognition. There you go. Yeah, and if this has been helpful to you, or you think this is interesting and have projects you want us to work on, kindly do well to subscribe to the channel, share with your friends, ask them to also join and share, and let's have fun on the project. Now, before we finally go, so what is the project for this quarter? So the project for this quarter is going to be an AI-enabled smart bin. Okay, AI-enabled smart bin. Now, I have that way behind me. Should I bring it? Yeah, well, yeah, they need to know. Bring it for them to see. Okay, all right. Let's do this. All right, so now this is huge. I don't know how I'm going to do it, but okay. I'm going to put this here. Now, this is a huge bin. Okay, already it has its own step on it to open all that, but we're going to change this. It has a baby one in there. Now, this was version 1 of it. It has, as you can see here, it has ultrasonic sensor here that if you wave, there's a servo motor in that would open this up. Or there's one here. If you use your foot, we can hide this. If you use your foot, it would also open it up. All right. Now, well, when I did this, I was like, I feel this is just. Let me put this back in here. Okay. Yes. So I felt that this was just the first version. Very simple there to go. But what if we could have one that is smart? That is AI powered. Now, when I mean AI powered, one of the problems now is segregation or separation of types of waste. Paper, plastic, metal, all that, organic, all right? So, would it be cool if we had a bin that would only open depending on what the model has been trained? So, if this is only going to take bottles, if you only show bottle to it, unless it sees a bottle, plastic or paper, depending on what you set, that's the only time the lid is going to open for you to drop it in. And also have the same features of the previous one, which is, hey, I'm getting full, open me up. And then also put a lock mechanism that, hey, you cannot just open and drop it there. It's going to be locked, only unlock and open on its own. So that is the project for this quarter. And the more reason why we're building incrementally on what we're doing. So the first part would be putting the various sensors we want to put here. So there's going to be, we're going to put some AI, we're going to put some cameras on it. And then one of the boards will run TinyML. We'll probably use Lobe AI or any of the AI, tools out there. We'll just pick one. We might be building it across all my shows. And this is why. So we might use the TinyML, we'll learn TinyML on my Friday show, which is Tech AI, and deploy that on the board on IoT Tuesday, and then use Power Platforms to build the UI. So what's going to happen is that it's going to be Wi-Fi and Bluetooth compatible, so definitely ESP is going to happen in there. It's going to send the data to the cloud. There's going to be some tiny ML processing on the edge that is going to determine whether it's paper, plastic, and all that to allow it to open. And then it's going to send the telemetry, the open telemetry, so anytime it's open and it's dropped, the capacity or the volume telemetry as well is going to be sent to it. And we can do some analysis if we want to. So if this sounds like interesting to you, something you want to see for the next quarter and the next God knows how long this show is going to continue, please make sure you subscribe here. Just hit the subscription button, hit the bell, the notification icon, so that if we drop any video, you're going to see it. It's 3:09. We're exactly 1 hour as we started, but I promised I was going to show you how to create the consumer group in the IoT Hub in the Azure portal. So I'm going to show you that, and then we'll call it a day. But if you have any questions, please drop it in the chat, or send it to any of my social media handles on the screen, and I'll do well to respond to that. Let's go back here and see what's happening. What we're waiting for our Azure portal to load for us to, put in, create a consumer group. I'll show you how the consumer group is created. So stay with me while that's happening. I think I should get some background music, going. Some background music, like, some very nice African rhythms playing in the background, that would be cool. Yeah, I should do that. Yeah, totally. And if you think our project for the quarter is interesting, thumbs up, send ideas, proposals, let's build and have fun. Seems like it's a bit slow. I don't know why. This should have hint. Error seen. Oh, an error was seen? How is that? Come on. Waiting for data. Look. We don't want to go beyond our time, please. Okay, let's do this. Let me try this again. There you go. Yeah, you needed some pumping. Don't mind them. All right, so let's go here to IoT Tuesday Hub. You can see I have, as of today, I've sent 846 messages, right? See that? So yeah, it's 864 message used today, 864, right? As you can see that. Now my daily messages quota is 400,000, and I've only used 864. I have 4 IoT devices using this hub, all right? That is using this hub. So if we go to building endpoint, so let's go to building endpoint, and there you go. So now you see that the consumer groups here, we have the default consumer group, right, which is what the hub will use to get any data coming in. But then we created one called telemetry. So if you want to create another consumer group, it's just enter the name of the consumer group here and save. That's it. You've created a new consumer group, and you can use that consumer group for every application. So we can actually create, so here we can actually track the event or run queries, all right? And queries here would allow us to say, hey, when the data, or when data coming from, if a data is sent to this topic, all right, send this data to this edge or this service or this event or whatever that is, right? And that's something that we'll be seeing a lot more of in the subsequent series to come. So today we're done with the SDK. Now we're going to focus on this between the data, sending it to Stream Analytics, Power BI. We're going to see all that in the subsequent episodes in lieu of building this project. So if that was exciting, if you liked it, give us a thumbs up, subscribe to the channel, tell a friend to tell a friend to tell a friend to join and share and subscribe. We can grow the channel and learn more till I come your way again next week. It is adios from me. Stay safe, learn something new. Let's make the world a better place through technology. I'm yours truly, Samuel Adrani, and I am out.